Okay, this is for Algebra 2. This is the review on radicals. This first problem wants you to graph this radical and then list the changes that happened to the parent function. I would recommend listing the changes first. If you look at the end, that -1 makes it go down 1. And then if you look inside, that x plus 3 is going to make it go to the left 3. For the test, I would recommend you looking at your thinking map and going over all these transitions. So looking at your graph, if your vertex or your starting point went down 1 and left 3, down 1, left 3, and then there you're going to have your graph. You could also look at your calculator to see what the graph should look like. This one, they're going to give you the changes and you have to give the new equation and what the graph looks like. So it reflected over the x-axis, so that would be a negative at the beginning. It went to the left 4 units, so that would be an x plus 4 inside. And it went up 5 units, and so that would be a plus 5 at the end. So if it went left 4 and up 5, left 4 and up 5, and then that reflection means that it goes down instead of up. Once again, you could put that in your calculator to see what the graph looked like. You need to make sure when you put it in the calculator that you close your parentheses after that x plus 4. And if you were to have to solve, you isolate, which is already done, so you're ready to square both sides. So 2x minus 4 is equal to 144. You're going to add your 4, so 2x is equal to 148. Divide by 2, x is equal to 74. You're going to want to start by moving your x and adding it. So the square root of 2x plus 14 is equal to 3 plus x. We've isolated, so we're ready to square. Be careful on this. You must put this in parentheses before you square. So on the left, it becomes 2x plus 14 is equal to, on the right, you have 3 plus x closed squared. You could write it twice, distribute and all that, or you can let the calculator do this for you. When you square that, you know it's going to become quadratic. We know that to solve a quadratic, you have to get everything on the same side. So the 2x and the 14 have to move. So when you move them, nothing's left, so 0 is equal to 3 plus x squared minus 2x minus 14, because I took each of those from the left side over to the right and did the opposite. You're going to put this in your calculator at y equal, and you're going to go either pull up your table, look for where y is 0, or second calc number 2 for 0. You will have two answers, x is equal to, x is equal to. So I'm going to go to y equal, and clear out what I have. Open 3 plus x close squared minus 2x minus 14. I'm going to start by looking at my table just in case. And it's going to show up using my table. I'm going to get x equal -5 and x equals 1. When there's a number in front of your square root, move it by dividing. So divide both sides by 5. And we get the square root of x plus 3 is equal to 9. We're going to square both sides. So x plus 3 is equal to 81. We're going to subtract the 3. X is equal to 78. Number 6, you need to start by adding your 3. So the square root of 4x is less than or equal to 5. We're going to square both sides. So 4x is less than or equal to 25. Divide by 4. And x is less than or equal to 6.25. Which equation matches the table? What I would do here is put them into y equal. So second x squared, x minus 1, close parentheses, plus 3. And second x squared, x minus 3, close parentheses, plus 1. Go to my table. Go to where x is -2, -1, 0, 1, 2. You need to have an error for all three of those, and then at 1 you need to have 3, and at 2 you need to have 4, so it's going to be A. Okay, so just put those in y equal, go to your table, compare the table on your calculator to the table on the paper. Which is the correct graph? Well, there's two things. You could use what you know about transformations, or you could put it in y equal and look at the graph. I'm going to do both just to make sure. I know that if I have a +3 at the end, that it went up 3. I know if I have a -1 in with the x, it's going to be horizontal, it's going to do the opposite, so it went right 1. So up 3 and right 1, yes, that works. No, that doesn't work. So that means it's A. Other thing you should realize is that this one goes down, and so it had a reflection over the x-axis, which does not show a negative at the front. Once again, you could also put it in at y equal, look at your graph, and see which one it looks like. Can you solve the problem, why or why not? We really didn't talk about this, so I would probably take each answer as long as you justify it. Okay? Here is the thing. The square root of a number is not really going to be negative. Except, if you want to tell me yes, the way you would justify it, your y, would be that the square root of 25 is equal to plus or minus 5. Which would mean that it could equal -5. Okay? Sometimes when you look at a problem, they're going to say that you can't do that because you can't have a negative. The thing of it is, if you squared -3, you would get a positive number. Like right here, if you took this, square root of x is equal to -3, and you squared both sides, you would get x is equal to 9. Well, the square root of 9 is either 3 or -3. So that's why I'm saying that yes, you could justify it. The important thing on this is that you not just say yes or no, that you answer the why or why not. If you use logic, you're going to be able to convince me either way. Inverse. Remember, for inverse, you start by swapping the x and y. So x is equal to the square root of 3y plus 1. We need to solve this for y, so let's square both sides to get rid of that square root symbol. So x squared is equal to 3y plus 1. So now we're going to say x squared minus 1 is equal to 3y. And then we're going to divide both sides by 3. So f -1 of x, because that's inverse, is x squared minus 1 all over 3. Reasonable domain. You take what's under the square root, so x over 5, and set it greater than or equal to 0. You always solve it that way. So if I multiply both sides by 5, I get x is greater than or equal to 0. That is my domain. So to get your range, you go put 0 in. Y is equal to the square root of 0 over 5. So y is equal to square root of 0. So y is going to be greater than or equal to 0 for your range. It's not always going to be the same. Okay? But you put it in, you see what you get, and then you say y is going to be greater than or equal to that. Changes to the parent function. We have a negative at the beginning, so it reflects over the x-axis, or you can say it flips over the x. That -3 in there at the x is going to send it to the right 3, and the plus 1 at the end is going to send it up 1. Study your thinking map if you don't know these. Solve for b. So start moving things around and getting b by itself. So we're going to have d is equal to 1/2 pi b squared. Let's start by multiplying both sides by 2. So 2d is equal to pi b squared. So now let's divide by pi. So now you have 2d over pi is equal to b squared. So now you have to unsquare it by doing the square root. So b is equal to the square root of 2d over pi. Then they want you to solve it, so you're going to go b is equal to the square root of 2 times 1210 all over pi. And if you notice, I never used this a. There should have been a at the end. There should have been an a at the end there, which meant we should have divided by pi a, which means there should have been an a there, which means we're going to put 11 there. So now you're just going to take your calculator and you're going to do second square root of, open a new set of parentheses, so you can do 2 times 1210, close the first set of parentheses, divided by, open a new set, pi times 11, close for the bottom, close for the whole thing, enter, and b is equal to 8.4. Sorry about messing up with the a. If y'all are confused about that, want me to rework it, come see me during speed and I will. Domain. All I care about is what's under the square root. The plus 1 does not matter. X minus 3 is greater than or equal to 0. Move your 3. X is, sorry, my writing got pretty bad. Move your 3. X is greater than or equal to 3. That is your domain. Solve. Start by moving this 1. So x minus 3 minus 1 is equal to the square root of x minus 3. Combine those, x minus 4 is equal to the square root of x minus 3. Square both sides. Make sure and put parentheses here. X minus 4 squared is equal to x minus 3. Add that 3 and subtract that x because it's quadratic. You need everything on the same side. X minus 4 squared minus x plus 3 equals 0. But put that in your calculator at y equal. Open x minus 4, close squared, minus x plus 3. Look at your table. It's not going to show up. So second calc, number 2 for 0. Get before it crosses the x-axis. Enter. After it crosses the x-axis, enter, enter. X equals 3.4 is one solution. Do it again. Second calc 2 for 0. Before it crosses the x-axis, enter. After it crosses the x-axis, enter, enter. X equals 5.6. Those are your solutions. Graphing this, well, here's the thing. It went up 1. It went right 3. We had a vertical expansion of 3. So you go up 1 and over 3. That's where it started. A vertical expansion means it's steeper, so it's something like that. If you weren't sure, you'd put it in your calculator, you'd look at the graph, you'd get some points off the table, you'd plot them, you'd have it. So this is the review for radicals. If you're not sure about something, you need to come see me during speed, and then you need to take your test tomorrow. Come see me during speed if you have questions.